Thank you, Karen. I wanted to read a few verses from Psalm 8. Listen for God's word to us. When I look at your heavens, the work of your fingers, the moon and the stars that you have established, what are human beings that you are mindful of them, mortals, that you care for them? O Lord, our Lord, how majestic is your name in all the earth. Harvard University has a building that's called Emerson Hall. It's the philosophy building. It was built in 1905. And when construction started, the plan was to have in big, bold letters across the top, man is the measure of all things. But the president of Harvard in 1905 had a different plan. He talked with the builders, and when the building was finished and unveiled, people were shocked to see at the top it said in big, bold letters, "What is man that thou art mindful of him?" Tonight, we are holding on to two ideas, those two perspectives, because tonight we're here to learn about artificial intelligence. And we're here to marvel at what human beings can do, what we will be able to do, the machines we can make, and what we will do in partnership with those machines. But we're also here to be humbled, not just humbled by those accomplishments, but also humbled by the responsibility and the danger and the wisdom that is needed to use this gift wisely and well. Let us pray. Oh God, we thank you for Ness, and we thank you for his family. We thank you for their presence here, and we thank you for Dr. Shroff's teaching tonight. And we pray, oh God, that you would help us to learn and help us to apply what we learn for good, for blessing, for us and for many near and far. We pray this with thanksgiving. Amen. It's my honor now to introduce tonight's special guest. Nesby Shroff received his Bachelor of Science degree from the University of Southern California, his MSE degree from the University of Pennsylvania, and his MPhil and PhD degrees from Columbia University. He taught at Purdue University before coming here. He came to The Ohio State University in 2007. He holds the Ohio Eminent Scholar Chaired Professorship in Networking and Communications. His research interests span the areas of communication, networking, storage, cloud, recommender, social, and cyber physical systems. Doesn't that sound great? He is in the Thomson Reuters book, The World's Most Influential Scientific Minds. I said, wow, when I read that too. Please join me in warmly welcoming Dr. Ness Shroff. Thank you so much. Do I need to speak in the mic or is it? Yes.
It'll help,
Okay. All right.
yeah.
Okay.
Yep.
All right. Let me hold it back.
That'd be cool.
Okay. Thank you once again, Pastor Tom. It's a real pleasure to be here, and it's a real pleasure to talk to all of you. As the pastor says, I'm Shroff. I teach at Ohio State, and I plan to have this to be a discussion on artificial intelligence. While you can certainly ask questions after the talk, if there is something that's not clear to you during the talk, feel free to interrupt me and ask questions during the talk as well, so that we can have this more of a discussion rather than just a one-way kind of lecture. All right, so let me begin, and let's start moving. So that's not a good sign.
I think.
Okay, that's next, but okay, all right, perfect. Okay, now, okay, so here is the outline of what I plan on presenting, and this outline was actually created last year based on a talk I gave not too far away from you at the Worthington Library, and the librarian had prepared a set of questions for me, and hence the presentation. So what I'll do is I'll start by introducing artificial intelligence, talk a little bit about some of the current uses of AI, which might be familiar to you, might be surprising to you, as well as some future uses of AI. Then we'll touch upon a few of the ethical concerns with AI, and there are lots of them. I won't have time to go through all of them, but we'll cover a few of them here. Talk a little bit about regulations and guardrails. Certainly, people are very, very interested in understanding what are the potential, impacts on jobs. So we'll discuss that as well. And then something which AI poses a very, very grave danger to us, which is about disinformation. We'll talk a little bit about that as well. And then we'll discuss about AI becoming sentient, because again, lots of folks have questions about that, and then I'll conclude. So with that, let me begin with the introduction to AI. So what is artificial intelligence? Well, artificial intelligence, as you can read there, is a branch of computer science, electrical engineering, and mathematics that aims to create machines and software that's capable of performing tasks that usually require human intelligence. And that's sort of the formal definition of AI. But what I'm here to tell you is that AI is not a monolith. It is actually many, many different things. It's like saying, what is cancer? Right? Throat cancer is very different from bone cancer, is very different from prostate cancer. So the AI is in that sense similar. There are many, many different AI tools and functionalities. And when you talk about AI, it's a good idea to talk about particular functionalities of AI. For example, one of the ones that is most visible is this idea of deep neural networks. And I'll briefly discuss those. There is also a very important component of AI. I work in that area quite a bit, which is that of reinforcement learning. So, it's sort of part of machine learning, how you learn progressively over time and you improve your actions. And there are many, many other areas of AI as well. And oftentimes when you talk about AI, people use AI and machine learning synonymously. Now, while they are not exactly the same, most modern AI is machine learning. So machine learning is actually a subset of AI, is a subfield of AI, but has now encompassed almost all of the current AI that's out there. Yeah. So here are some
examples of the different applications of AI and machine learning. Reinforcement learning for self-driving. You have deep neural networks that are used for image recognition and classification, and both of these together are used to create large language models, which are the models that you're familiar with, things like ChatGPT, Bard, and so on. All right, so let me begin by giving you a little bit of the history of AI. And if you ask AI experts, when does AI actually start? You're likely to get different answers. So here is my answer. So my answer is AI actually begins with Alan Turing, who is the founder of modern computer science and the inventor of the Turing machine, or the universal machine, which was the first conceptual computer, and also the creator of the Turing test. So how many of you have actually watched The Imitation Game? All right. So you know what the Turing test is. It's basically a test to determine if a machine can exhibit intelligent behavior. And that's essentially what started this area of AI. Another person who I think deserves enormous recognition for AI is a scientist named Claude Shannon. He was an engineer at Bell Labs, and he created this field of information theory in the 1940s. So the notion of the bit, the ones and zeros that makes up all your computers, the digital circuit, Boolean algebra, this all came about because of the brilliance of Claude Shannon. He really is the father of the digital age, and no computers, communication systems, or artificial intelligence of any kind would have been possible without him. And finally, most AI researchers talk about this famous conference called the Dartmouth Conference in 1956, which they determined was the birthplace of AI. And the reason for doing that was because there, a program called Logic Theorist was actually presented, which was the first time a computer program was able to generate proofs all by itself for a variety of problems in a famous book called Mathematica Principica. All right. And what was interesting is that it came up with 10 proofs, and 9 of them followed what humans would follow, but one of them came up with a completely novel proof that no human had created before. So that was why it's often referred to as the birthplace of AI. All right, so after the Dartmouth conference, there was an enormous amount of excitement about AI. There was, a feeling that artificial intelligence was going to be real and going to be real soon. And we would soon have robots that would clean our homes for us. We would have technologies that would drive us around. So people were already thinking of those kinds of applications. But as you can see, those did not materialize. So while there were some AI summers where there was a lot of interest and a lot of excitement, it was also followed by a lot of disappointment. So a lot of winters were there as well. But in the academic world, as well as in industry, there was a steady and fundamental progress that took place even during those down times. And there were foundational advances in machine learning, in expert systems, that then came to fruition when Deep Blue from IBM, which was this wonderful computer program, beat the great Gary Kasparov. Now, for those of you who don't know Gary Kasparov was a genius at chess, is a genius, he's still living. But he was so good that it wasn't just that he was the best in the world, but he could beat the next 10 players playing them simultaneously. He was incredible. And so when Deep Blue created a program to beat Gary Kasparov, that was a huge achievement. In fact, I was at Purdue at that time, and the authors of Deep Blue came and presented the solution to us. And it was, I still remember that time of great excitement. So 2010 onwards, AI started to go mainstream. So why is that? Can someone correlate something that happened in 2010 that made AI go mainstream? Any ideas? Very good. The iPhone. What else? And social networks. So basically what happened is computers like the iPhone essentially became, much faster and cheaper. And then you had this tremendously data-rich environment, which resulted in the explosion of machine learning techniques, recommender systems, etc., and which is why you have those annoying ads every time you go on Google. You can blame me. And then 2016 onwards, the intersection of these computers becoming much faster and data becoming more rich allowed us to create even more sophisticated programs. And one of the biggest breakthroughs came when AlphaGo beat the world champion in the board game Go. Now, why was this different? So chess has a certain set of rules, and it was expected that if you had a very powerful computer, you could just do even brute force enumeration to come up with solutions that were better than a human. So right now, for example, even a small device like your pocket phone will beat most grandmasters, okay, just because of the raw computing capability. But the game of Go is a very complex game, and it was thought that no computer would ever come close to beating the human in Go, because there were just so many different things that one had to consider, and it was not easy to even quantify them. So it was a big surprise when DeepMind, one of Google's subsidiaries, came up with this program called AlphaGo, which beat the world champion in Go. By the way, this is an Asian game. I believe it has Chinese origins, but the world champions for a long time have been from South Korea in this area. And then in 2017, there was an even bigger advance that took place. Not only did you have a program that beat the old program that beat the world champion, but this program did it without any input from humans. So the way it worked was it used reinforcement learning, where essentially all it was told were the rules of the game. And then it played with itself millions of times to get better and better and better. And then beat AlphaGo. So this was a huge advance. And then AlphaFold in 2020 solved the protein folding problem, which is a very, very fundamental problem and in biology, which is to characterize proteins. And in fact, my daughter is here, and one of her friends in a PhD program was fortunate enough to graduate just before AlphaFold came about, because she was characterizing one protein. And typically it took an entire PhD to characterize one protein. And AlphaFold characterized all known proteins in the world, right, in one shot. So it predicted the 3D structures of every known protein and advanced biology significantly. Huge, huge. And then, of course, there was already growing interest in developing large language models like ChatGPT and so on. We've been talking about this since 2010, and in 2022, ChatGPT came out, and then the interest in AI has just grown exponentially since then. All right, so let me now talk about one of the functionalities of AI. It's an important pillar of AI, which is deep learning. So this is a subfield of machine learning that uses artificial neural networks that you can see on the right there, that figure there, with many, many layers. And deep just means that the layers are deep. And the idea is that these deep structures are used to extract high-level features from the data. And I'll explain how it works in a moment. But let's first talk about the typical components in deep learning. One of the big components is ensuring that you have a large data set, which means you have lots of data. You also, for a lot of these deep learning problems, you need enormous amount of computing power, which is why there are these companies like OpenAI and Google and so on that have these huge number of servers at their disposal. And of course, good algorithms. This is where we all come in, the ones that are designing these algorithms. And then there are two components to this. There's a training phase where you train these artificial neural networks on a large amount of data to find patterns or features in order to make accurate predictions, to say, hey, is this a cat? Is this a dog? Is this a tree? Right? And then you have a testing phase, which tests this neural network, not on the data it was trained on, but entirely new data to see how it does. And if it does well, great. If it doesn't do well, you have to do more work. So that's the high level idea of deep learning. But let me kind of get into a little bit more detail. So let's say you want your computer to recognize a cat. We do it naturally. And how do we learn, right? We learn through examples. So in the training phase, we need several hundred training images with labels. Label simply means that some images are called cats, some images that are not cats are labeled separately, like horses or dogs or whatever. And then you feed these images and labels into a neural network. So the way you do that is you basically take a picture, you break it down into a vector of pixels. This picture has little points on it. And then these pixels are just ones and zeros. You push them into the neural network. And then the neural network has a lot of adjustable parts called weights. And these weights are initially set at random. And then for each image, the neural network makes a guess. Is this a cat or not a cat? If it guesses wrong, then the network will update its weights according to some algorithm called a backpropagation algorithm to correct the guess in the next time slot. And now, if you train over hundreds of images, the neural network begins to develop the ability to recognize specific features, like the cat has a pointy ear, it has a certain set of whiskers or tail, etc., etc. And then the training phase typically ends when the neural network, with its weights, is able to recognize cats with very high probability. So let's say it says, okay, as long as out of 1,000 pictures, you can recognize a cat accurately 990 times, that's good enough, right? Because probably humans are just as fallible, for the other 10. And then you have a testing phase. You now say you have a completely different set of images. You ask the neural network to identify a cat from these new set of images. And if that happens successfully, great. If it doesn't happen, you go back to the drawing board. Maybe you need to redo the training phase. Maybe you need better neural network models. Maybe you need better data. And then you repeat. That's just the sort of the very high level umbrella idea of how these deep neural networks work. Okay. Any questions so far? Yes.
So for these pictures, is it going pixel by pixel?
It is. So the question was for these pictures, is it going pixel by pixel? And the answer is yes, you feed it pixel by pixel, but it's done instantaneously, obviously. Yeah, it's quite interesting, actually. You know, I have a postdoctoral researcher who's come up with a solution where he is sending images from, let's say, a car, okay, and they are being sent, to a central server to detect. And the idea is that the computing resources in a vehicular environment or whatever is very limited, so you can send very little amount of information. And what happens is that the algorithms that the machine uses that are good makes the image to humans look like noise. It just looks like random pixels, but the machine is able to recognize them immediately. In fact, when the pictures look somewhat legible for us, it's not the right way the machine recognizes. So they recognize it in a different way than we do.
That's,
Yes.
if the first time it doesn't say it's a cat, what or who tells it you are wrong? Go back to the.
Right, so that's why very good question. So the pictures are labeled. So you can either have a human person tell it, or you can automate it with a program which basically says, hey, this was identified, this was misidentified. Because there's a database in which you can store it and provide the input to the neural network in an automated way. So all of these, so this is data which is labeled. So each image is already identified by a human or otherwise as being a cat or not a cat. Yeah.
How is the system efficient? Because you have to pay like, thank you, millions of images or whatever.
Yeah, so in all of these, so one of the things, so the question was, how is the system efficient? Because you have to feed in a lot of images. And that is absolutely true. So if you think about how do humans learn, right? Humans learn over time by observing things, right? So for example, how does a baby recognize patterns, right? It sees, various trees and eventually it says, that's a tree. Right? It sort of takes in a large amount of data in order to be able to recognize. And so the same thing with this. You need a lot of data in order to make a decision with a certain degree of accuracy on whether this is a cat or not a cat. Typically, hundreds of images are good enough for this type of a binary decision. But for more complex things, you might need thousands and thousands of data points.
So some human has to put all this data in?
Some human or some database where the data is already there. So, there are, for example, images, that are labeled, with humans, of course, typically. Yeah.
Because that's,
So this is a question of ground truth. How is the ground truth established? This is the ground truth. And the ground truth is established, through humans in this type of a mechanism, but in other mechanisms, you might use a different program to develop the ground truth.
so with all the movies where all this data, they start taking over. Is that gonna happen? Is that even possible? Is that just far-fetched movie stuff?
What is the question?
What's the best movie, what's the movie that came out with Arnold?
Terminator.
Terminator, okay, there we go.
Yeah, we'll get to Terminator later. Let me reserve that for a little bit later. Yeah. All right, so in 2017, there was a very, very interesting paper that came out, which was called Attention is All You Need. And that paper came out in 2017, which basically created a new architecture for neural networks, which allowed it to sort of make correlations in a very efficient way, which greatly improved the performance of natural language processing. And so that allowed these large language models to really take off. And that's a collaboration that happened between researchers in universities and researchers in companies. And these large language models that we are so used to are really built on these neural network transformer architectures that are trained on a vast amount of text data. So if you look at ChatGPT, ChatGPT is trained on almost all the data that's out there in the world. Okay, it's fed, all this internet data is sucked up in the pre-training process. Then there's a process of fine tuning, you kind of improve it. And then for a small subset, you actually have humans verify that ChatGPT's answers are right. So you essentially have this notion of reinforcement learning from human feedback. So you keep improving the program using human feedback. And this allows these programs to be capable of generating human-like text. They can write a story for you. They can write a comic routine for you. They can create pictures for you, which allow it to work with a large variety of things, right? Like right now, if you want, you can create a contract. You can say, hey, I am starting a new company. I would like a contract. You give it a start date, you give it an end date, and ChatGPT will give you a contract, right? So there are various versions. There are many language models. I'm just using ChatGPT as an example because that's the most popular one, but there's Bard and there are hundreds of others. All right, so let's talk a little bit now about current and future uses of AI. So, do most of us who don't, say, for example, use ChatGPT already use AI? What do you think? Yes, we do. See, all of these applications that you see scrolling down, they all use AI. If you do a search on Google, it uses AI. Voice assistants like Siri and Alexa use AI to recognize voice. These recommendation algorithms, as I was saying, those annoying ads on Facebook or Google, use AI. In fact, this is how they operate. This is how these social networks live. That's their bread and butter. That's how they make money. Email spam filters, AI. You can write an email right now with AI. You can kind of give it rough parameters and it'll create an email for you. Navigation apps, smartphone cameras, you name it, uses AI. Now, how will we use AI in the future? And here really the possibilities are endless. Here are some examples. I think healthcare is going to be revolutionized using AI. So I was just telling Tom that last year I was invited by the Wexner Medical College to give a talk at one of their graduation ceremonies of their MDs on AI. And so I had to do a bit of research on that. And I provided them several examples where even simple neural network-based solutions were already doing better at predicting diseases than specialists. So this is something which is really taking off, and it's just going to get better. How many of you watch Star Trek? Are there any Trekkies around? Okay, there are some Trekkies around. Good. So you remember that universal translator in Star Trek? Well, that's not too far away. That's going to happen. Right? Autonomous vehicles, intelligent transportation. You already see robo-taxis operating in San Francisco and Phoenix and so on. Very important application of AI is going to be customized education. So how many of you know about the Khan Academy? Anyone? Few, yeah. So the Khan Academy actually uses the advanced version of ChatGPT, GPT-4, to create personalized tutoring for kids who are underprivileged communities, including kids in Africa, etc., who don't have access to teachers. And what they found is these personalized mechanisms of teaching with AI improve their kids' scores from 1 standard deviation below the mean where they start off with to 1 standard deviation above the mean. So there is such an enormous potential for using this for improving people's lives. Right? One of the things that my own institute is working on is developing future communication networks. So removing the shackles of geography from communication systems. That's a big thing. All right, so lots and lots of applications of how we will use AI in the future, but they also bring some serious ethical considerations. So let's talk about a few of those. So many different ones, and I'm going to talk about the first three. So let's begin with bias and discrimination. So the problem with AI and AI models is that these models simply reflect and amplify the existing biases that might exist in society if the training data itself is biased. And this could lead to real problems, especially if you start to overly rely on these models. So let me give you an example. There is a metric called the Framingham risk score, which is being used to determine, cardiovascular risks in populations. Now, it turns out that the Framingham risk score significantly underestimates the cardiovascular risks in Black and Hispanic populations because it wasn't developed with that data in mind. And so if you start to build AI models on this Framingham risk score, then you're much more likely to come up with outcomes that are detrimental to those populations. So there are ways in which you can counter these type of biases. You can ensure that the selection of your data is done in a way that your training set is representative. It has, it sort of makes sure that even data which is rare is included in that set. And then, of course, you also want to ensure that you are constantly monitoring and periodically auditing to see how these outcomes that the AI tools are generating are actually working in practice, and then tuning your models based on that. So those are some of the things that one can do. This is an active research. It's this careful selection of diverse data is something called importance sampling. It's a very important tool used in mathematics for calculating rare events, which can be used here to make things more fair. Another issue is trustworthy AI. So AI is used, as we saw, for many different applications. These could be mundane applications like sentence completion, voice text recognition, to more sort of extraordinary applications like automated driving, automated transportation, scientific discoveries like the protein folding problem. In all of these, if you want to have trust in AI, you need the AI to perform consistently and accurately, right? This is one of the reasons why, for example, we get annoyed when we're writing an email using Gmail and Gmail gives us suggestions which we don't really want and kind of is just annoying. Or when we are typing something on our iPhones, they'll change what we've typed to something completely irrelevant and it just annoys us, right? So if it does that, we don't have trust in it. So even for simple things, we need to build these systems so that we have trust in them. And then, of course, we absolutely need to have trust in safety critical applications, whether they be medical applications or automated driving applications. Otherwise, one could have catastrophic consequences. And this brings a number of challenging questions that we as a society will have to grapple. So the first one is, how does one ensure that AI operates safely and what it's meant to do? So this means the algorithms need to be improved, they need to be tested better, etc. But the question that we need to really think about is, should we expect perfection from AI when we don't expect perfection from ourselves, right? So if self-driving cars reduce fatalities by 50%, okay, is that good enough? Should we trust self-driving cars? Or do we want the fatalities to be reduced to 3% of what it would be with a human? Right? What is the right number? These are questions that one needs to think about. Same thing with disease prediction and surgery. So if the AI, for example, improves your prediction from 40% to 70%, it's still wrong 30% of the time. Does that mean that you don't trust it? But you trust your doctor when the doctor is making mistakes 60% of the time, right? So what are the opportunity costs of not using AI in those types of situations, right? It's like the stock market, right? Sometimes you lose money, sometimes you make money, but then if you left all your money in a CD that's making only 1%, you've lost a lot of opportunity costs. Same thing here. How will AI react to dangerous situations? There's a classical sort of philosophical question where if you're driving and you have two options, you basically hit one person or you hit 5 people, which one do you choose, right? And the same thing would be in AI. Would AI be forced to crash a car and kill its driver in order to save the lives of, say, 3 pedestrians or 5 children? What should the AI do? And who is responsible to make those decisions? And when those accidents happen, which they inevitably will, who is liable? These are all questions that we as a society need to grapple with, and soon. Then there is the big impact of AI, which is an environmental impact of AI. You see these, these queries that ChatGPT answers. Each query, again, I haven't read this in a scientific place, but I've been told by researchers at Facebook that each of these takes roughly 3 cents cost. Okay, which means that what is the cost? The cost is energy, the cost is electricity. So you can imagine the enormous electricity costs that these data centers need to use. And then they have to be continuously cooled to prevent these servers from overheating, which means they take huge water consumption. So one generated email that's AI generated of approximately 100 words, I just found this today, requires roughly 1 bottle of water. Which means that these technologies are actually creating water shortages in certain places. This is a very serious problem and needs to be handled carefully. There's also the issue of electronic waste. Yes, please.
Going back to the water consumption.
Yes.
How much of that can be recycled? I think they could keep using that water over and over again.
It has to be cooled though in a particular way.
Yeah,
Right?
needs energy.
Yeah,
to cool
yeah.
it,
So
but they could use.
yeah, you
They
could.
won't really be net losing a lot of water, will they?
I think they do. I think
Oh,
they
they
do.
do.
They do. They do lose a lot even
Yeah,
on water. Yeah. Electronic waste is a big problem. And then there's resource extraction. A lot of the AI hardware requires raw materials, including rare earth elements. And the extraction and processing of these materials can lead to significant problems on the environment, on the habitats, right? And also, there's another problem. A lot of these rare materials are not available in the United States. A lot of them come from China. And actually, Xi Jinping just today announced an order that in retaliation for the tariffs that are coming down on China, they are not going to permit rare earth elements to be exported from China. So this is going to be a serious problem. Okay, there are also some positive impacts of AI. AI can also be used to optimize energy usage, come up with clever ways of solving the water problem or the energy problem. Oftentimes it can be used to predict and mitigate environmental disasters. So, you can move populations out of hurricanes through AI-based predictions. You can predict earthquakes, things of that nature that AI would be able to do that one could not do before. Yeah. So one needs to work towards good mitigation strategies. The most important are these first two, which is to make AI much more energy efficient. So can we use, for example, the hardware in this computer to solve the AI problems rather than having these ginormous servers that consume this huge amount of energy and water. Of course, use of renewable energy, etc., also can play a role in sort of mitigating some of these issues. All right, so all of this will need a combination of market forces, better competition, standardizations, as well as certain amount of government regulation to solve. All right, now let's talk about AI regulations and guardrails. And I have to admit, this is an area which oftentimes, while I have been asked to sort of provide opinions on, it's not my expertise. Okay, so I always give my opinion with some caveats. So several AI policy efforts have been undertaken. The Biden administration, for example, last year issued an executive order on safe, secure, and trustworthy AI, which was primarily targeted at large companies that employed more than a certain number of people to make sure that their products were safe. Also, they created a task force and advisory committees to sort of issue guidelines on AI. The Senate Legislative Council has also been doing this. In fact, we spoke to some of the staff from
Sherrod Brown.
no, not Sherrod Brown. Yeah, from the vice president who's Vance, Jay Vance's office. Sorry. Yeah, so some of the staff members that have come, that they wanted some input from AI experts in academia in order to come up with guidelines for the economic implications of AI and how that should be regulated. AI policy symposiums have been occurring over the last year in Washington, D.C., where they bring industry expert, academic experts, as well as governments. All right, we expect that the US will follow some of the guidelines that the EU has already started. I think the EU has created a set of guidelines that are actually quite reasonable. They've characterized AI into levels of risks. So obviously, for AI that's used for medical or healthcare kinds of predictions and diagnosis carries a different level of risk than, say, AI used for recommending movies to us. Right? So what they've done is they've made sure that those are much better regulated than recommendation of movies or email writing or things of that nature, which makes a lot of sense. US, as we know, the Congress in the US works really well. So regulations are still a work in progress, but we can expect some combination of standardization, which works very well with other technologies that's happening, AI regulations and standards that are adopted by the federal government. So for example, there are some AI norms that the federal government has been asked to sort of use and follow. And these have ripple out effects on the private sector because the government is a huge purchaser of commercial applications. And then AI regulations for certain large companies and institutions, which have to follow some safety guidelines. There are also some state-by-state efforts. Some of them are already underway. If you look at this link, you can see what the various states have for safety regulations with AI. They're still relatively in their infancy. I mean, you have to understand that the staff of these government officials are actually quite interested in doing the right thing. But the politicians themselves have no idea how to use a computer, let alone AI oftentimes, right? So it's a little bit much to ask them. So anyway, we need regulations that have clear guidelines for accountability and enforcement. But also, we want to make sure that this accountability and enforcement is flexible. So it allows for sort of, evolution of these standards as the technology changes. Because what you don't want to do is you don't want to regulate in a way in which it only benefits the large companies. If you put too much regulations, the only people that are going to be able to satisfy those regulations will be the very large companies. And the smaller companies will not have an equal playing field. So you have to do these regulations in a smart way so that, it ensures that there is an environment to create innovations and not curb them. All right, let's now talk about AI and job losses. So, a question that's often asked to me is what kind of job losses are in danger and what jobs are safe? And this comes up often when I give these talks. And the answer is truthfully, I don't know. But if I were to guess, jobs that involve a lot of routine and repetitive activities are probably the easiest to replace. So this would be like data entry jobs, manufacturing jobs, jobs that require simple decisions where rules can be easily established. For example, drafting a will, processing loans, creating contracts. These are jobs that AI could do quite effectively. If, and I had written if and now I changed it to when, because this is coming. When self-driving cars become a reality in a large way, this is very concerning to me because there are lots and lots of jobs involving transportation, food delivery, etc., that could be affected. Now think of the trucking industry. This is a huge revenue for a lot of people. There are 100,000 plus truckers in the US, and they could potentially lose their jobs. So this is a serious issue that is coming. But people with advanced degrees should not feel safe either. I mean, jobs, for example, for physicians and specialists, there are AI tools that are emerging that can make better diagnosis, as we said, than them. And you can imagine that a robot can do pinpoint surgery much better than a surgeon because, your fingers can only go that far. They're just that steady, while a robot can be potentially made to be far steadier. When I was giving this talk last year, one of my colleagues in the Wexner Medical School, he told me something interesting. He said that they did an experiment where a psychology AI tool was being used to provide remote counseling. And the patients, on average, like the AI psychologist better, he said, than they like the human, until they found out that the person on the other side was not real. Then they disregarded everything they said. But until that point, they actually liked them better because, AI tools don't get annoyed while humans do, as I'm sure you've experienced with your doctors from time to time. Some good news is that if you look at the history of technological breakthroughs, it is true that each major breakthrough can cause painful job losses. And that's no solace to the person who loses their job, clearly. However, they're almost always accompanied by entirely new job sectors that are developed. And so the population has something to look forward to in terms of new jobs. So it is quite possible that as these AI tools advance, we start to use them just like we use our calculators, right, to replace complex multiplication, division in our heads. And maybe these AI tools will allow us to do more creative things, will allow us to do more interesting things and not worry about our mundane responsibilities. Maybe, we'll have robots that fold our laundry and, do the washing and drying and ironing for us, right? That'd be pretty cool. All right, so now let me talk about something which worries me a lot, which is misinformation and disinformation with AI. So the question is, how does one handle inaccuracy of information? And this really has two forms. One of them is what I would consider inadvertent misinformation. And this, as you will see, is part of human errors. And the other one is disinformation, which is an active and targeted type of misinformation. So let's talk about the first. So the first one is due to the errors and limitations of our AI researchers, which means that the technologies that we develop have a lot to be desired, right? If you ask ChatGPT a question, sometimes it might give you some bizarre answers, right? For example, you ask it to produce some medical publications, and it'll create a list of publications that are not real. It just hallucinates. That's why this is called an hallucination. And this is something that we can work on. Designers are actively trying to reduce these. Not an easy problem because these systems are so large and so complex. But this is, already our large language models are getting better and better. They're reducing the amount of mistakes they make, reducing the amount of hallucinations. Still there's lots, but it is something which is workable. So what can we do as users of the technology, not as designers of them? You deal with it the way you would any new technology. You cross-reference information. You verify with reliable sources on the web. For example, if somebody says, hey, these are the publications, then you look for the publications. If they're not there, the AI was out to lunch, right? Something went wrong. If I'm using AI to write programming code, you double check that the code is giving you the output that you should get, right? Or go to the experts in the domain to verify that information. So these are things that one would do. The other type of disinformation is much more problematic. And unfortunately, it's built into the social fabric of these social systems. So it's much harder to fight. And this is malicious, intentionally malicious, or profit-driven. So it could be malicious in the sense of, we just came from an election, lots of lies that, have been propagated on various social media platforms, various, entities, foreign entities interfere, create, crazy conspiracy theories and make them appear to be real. These things happen all the time. And this is going to become even worse with AI because it's so easy to create false text or deep fake images or videos with AI. So I sort of call this reducing the cost of BS to zero. Right? Because AI can create a whole lot of nonsense with very little cost. In the past, you needed humans to create this. Now you can have an AI tool that can just flood the gates with nonsense. It can be used to tailor personalized information based on your preconceived biases. So if you, for example, believe in something which is not true, it can feed you information which just reinforces that belief. And this is one of the reasons why you find that our society is already so polarized, and it's getting more and more polarized. And unfortunately, expect to see a lot more of this in future election cycles or conflicts. Right? The problem is that companies actually benefit from this. Companies don't care on what their information is. All they care is making sure that your eyeballs are on their screen as much as possible, right? Because that's how they make dollars. And so they drive up the traffic, increase time on the platforms, magnify their profits. So what can we do? Well, as AI researchers, we are developing tools to detect AI fakes and disinformation, but it's a little bit like a whack-a-mole problem, right? You whack a mole and another thing pops. The other problem is, even when you label something as being untrue, people will say it's true, okay? Because it's so ingrained in their biases. And so it's a real challenge. And of course, as I said, it doesn't help that the revenue models for social networks are exactly opposite of countering and battling disinformation. Because they don't want this to happen, because once you do it, their revenue goes down. So some things that one can do is get information from reliable sources. I think here we need media literacy training, both of social media as well as the news media. We want to diversify sources of information to avoid polarization. So for example, you don't want Google to know your political preference. You don't want Google to know your technological preference. Because if they know your technological preference, they know your political preference, they will shrink the size of the universe that you will see. You will continue to see things that they believe you want to see. Okay, and you will keep going down further and further into that rabbit. So that's something which is very, very important to do. Okay, follow a trust but verify principle. Okay? Now, as educators, we need to build and encourage critical thinking skills so that not everything that you hear on Facebook or Twitter or whatever, X or whatever it's called right now, is considered to be newsworthy, right? And empower individuals to report disinformation and dispel it in social circles. So if you, for example, know the truth and your neighbors don't believe the truth, it's your responsibility to tell them what the truth is. It's even if you have to have difficult conversations. This is the only way we actually save our society from further polarization.
How do we prevent Google from shrinking what we see?
Question was, how do we prevent Google from there are several ways. You could, for example, search incognito mode, okay, so that Google doesn't kind of keep a history of you on that. You could occasionally, I mean, depending on what you want to search, you could, for example, search. Let's say if there's a, if there is a medical question that you want to have answered, you want to go to the, rather than just search on Google, you want to go to the authorities, the folks that actually kind of are responsible for providing you with information which is, medically relevant, right? So you can go to the Mayo Clinic, you can go to the Cleveland Clinic for your information rather than going to WebMD or something like that, right? I mean, you want to go to the right sources of information so that you're getting relevant information. But this is I don't have a silver bullet for this question. And my wife who asked the question knows that. All right. Finally, let's talk about a fun topic, which is sentient AI. So another question that I often get asked is, does AI have consciousness? And the answer is, in my opinion, no, it doesn't have consciousness. Okay, current AI systems really function based on algorithms and data processing. They do not have personalized experiences or awareness. And so they don't have consciousness the way we think of consciousness. And then the question that people ask, especially, whenever I talk to sort of folks in the media, they'll ask this question, which is, will AI eventually have consciousness? And this is one of those answers where I don't know. The only thing I can say is, if anyone tells you they know, they're either lying or they're missing, because they don't know. Now, my personal opinion, and this is, take it as just my personal opinion, is that if you look at current AI technologies, they operate based on a variety of algorithms, pattern recognition, machine learning, etc., which is fundamentally different from biological processes that underpin human consciousness. Although there are things like continual learning and so on that you can use to emulate the way humans learn. Okay. But creating consciousness in AI would likely require not just technological advances, not just making the programs more efficient, not just making the networks deeper or larger, having more computing power, but in my opinion, a very, very fundamental shift in our approach to building and conceptualizing these systems. But maybe in the end, all of it doesn't matter. Maybe it's all about the imitation game, which means that it doesn't matter that machines can really think or they're really conscious the way humans are. Maybe as long as they act and behave indistinguishably from the way humans do, maybe that means they're conscious. That's what Turing's hypothesis was, right? And maybe in some ways, they might exceed the capability of humans. They're already doing that. Right? So again, I don't have an answer to this, but this is just a thought. So to conclude, I believe in the potential of AI. There is enormous potential of AI to improve the human condition. We have opportunities to improve our lives in many, many different ways, to live longer, to live healthier, to have better comforts, to have better communication potentials, lots and lots of things that AI can help with. But we need collaboration that happens between domain experts and AI experts in order to realize these outcomes. So for example, when we are working on healthcare problems, you cannot have a person in computer science developing an algorithm on their own without collaboration with healthcare specialists. You need that collaboration in order to really make improvements. But all of us in the society will need to work together with AI developers, industry leaders, government officials, standard body, educators, etc., that AI is developed in a safe way, in a responsible way, in an ethical. And that's where I'll start. Thank you. Further questions? Yes, please. Can you use AI to mine for Bitcoin? Okay, that's a good question. So mining for Bitcoin actually requires enormous amount of computational power. Yeah. I don't know the answer to that question. I suspect that it's not that easy to do, because otherwise lots of people would be doing it, right? So what I would say is that it's not as simple as using, say, ChatGPT or something for mining Bitcoin. But certainly, in order to make the mining process more efficient, you can develop AI tools to do that. So I would say the answer is a partial yes.
just made a comment I was reading the other day. You're talking about energy and energy efficiency. The world's fastest supercomputer right now uses 30 megawatts of power.
Mhm.
Larry Fink, who is the CEO of BlackRock, commented the other day, I don't know if it was World Economic Forum or somewhere, every AI training center really needs its own nuclear power plant.
Yeah,
That's how much energy they take. And then Central Ohio is getting, I don't know how many data centers we have now.
yeah.
And
It's very much true. I mean, and so I've been told by colleagues, I haven't verified this, so this is a secondhand statement that OpenAI has the largest cluster in the world of servers, and it's so large that all of our national lab supercomputing capabilities put together is smaller than just OpenAI's cluster. Yeah. Again, I've heard this secondhand, so it needs to be verified, but from reasonably reliable sources. So it's a real problem. Yes, please.
I guess one of my concerns is that with more AI generated content out there, is AI currently learning from AI generated content, and is there a problem of misinformation? I guess just going really deep into AI as it learns off of its own misinformation.
Yeah, that's a great question, and the answer is absolutely. In fact, there is something called data corruption in AI. So it's not even about misinformation, it's just about how the models work. So for example, if you use AI, let's say you have data that's not enough to make certain decisions, and then you create more data based on that data. So you create sort of synthetic data, and then you use that synthetic data to train the models. You actually end up creating some real problems for the models, and that's a well-known problem. So you could actually end up having models that don't work well because the data is poisoned in this way, and so that's definitely an issue. So AI-generated data, if it's synthetically generated and is not based on ground truth, could create problems. Yeah. Yes.
Working in the educational environment, you're around students or interacting with them. Just your personal opinion, is AI enhancing their learning experience and their education?
It's a very good question. So the question was, is AI in an education space enhancing the students' education? So let me answer it in the following way. One now has to make sure that tests and homeworks are designed in a way in which the student uses AI as a tool to learn better. If you give the same type of material that you did before, then it's very likely that the student will use the AI in an incorrect way and will just obtain very shallow knowledge. So it'll be able to give you answers, but will not really, understand this. On the other hand, I can see lots of opportunities of using AI in a way to accelerate the student's learning. So think of, let's say, having a student write an essay in English, right? The AI, for example, could guide it to come up with a far better essay than he or she would have been able to do on their own, but not write the essay for them, right? So it's something where the AI could sort of help provide hints in order to come up with a sort of a final product that makes the students understand that some of the stylistic usage that the student was using was used incorrectly. Some of the grammar the student was using was used incorrectly. And so the student learns from that and improves. The same thing with coding. So, students right now can use AI and write code, which is not bad, actually. But if they just directly use it to write code, then you're not teaching the student anything, because all the student has done is solve this problem, generate the code, turn in the homework. On the other hand, if you ask the student to kind of show the process in which the code was written and what kinds of improvement the student could do with the help of AI, then the student learns how to write code in a better way and accelerates its own, their own sort of learning potential, so that they don't have to spend 10 years coding in industry in order to learn how to code well. They can actually use this AI to develop the right techniques, the right tools in order. So it's a double-edged sword. I mean, there are, if it's used in a poor way, then it would result in very shallow kind of outcomes. Yes.
AI is trying to solve for something. Are there any standards on the AI models as what they're trying to optimize for?
So the standards will come based on the problem domain. So for example, let's say if it's an image classification problem, then the standards would be that I need my image classification to be above a certain value, right? If it's a self-driving type of a thing, then you basically want the AI tool to, at least in an emulated environment, to make sure that they don't, crash the car or something like that. So it comes, oftentimes it comes from there, but there are notions, there are well-defined notions. So when we develop algorithms, we use a notion called regret. So what regret means is, it says oftentimes you use AI when information is not fully available. So it's like incomplete information. So the regret is the difference between an oracle giving you an answer, like a God giving you an answer, to what you can develop with AI tools. And that difference being as small as possible means that your algorithm is doing well. So one can actually come up with like lower bounds and upper bounds and then show that, okay, no matter what you do, you can never do better than this. And that's a sort of a well-grounded theoretical measure of what the AI tool can do for you. So it's a very commonly used metric. Yeah.
We all know that funds are not unlimited. And so from your experience, who's getting the funding? And how is the funding? You can't, it'd be nice if we could fund agriculture and healthcare. I suspect the military is really big into this.
Yes.
Could you talk about, you said Ohio State, how you determine how the funding is coming for the research?
Yeah, so as you're absolutely right, funding is very competitive. And so we have to apply to sort of national competitions in order to get funded as researchers. So the institute that I'm leading is an NSF-funded AI institute. It involves 11 universities, and there was initial investment from NSF, which is quite large for something that NSF comes up with, which was $20 million over 5 years. Now we've been able to get more resources from other places to supplement that, but that was sort of the initial investment. And this initial investment was for twofold. One was to develop communication networks of the future, and the other was to democratize AI. So basically use distributed solutions in order to solve large AI problems. So that's this institute. But there are several other institutes, including ones in agriculture. In fact, agriculture has, I believe, received 4 of these. So there's one at Illinois, there's one at Iowa State, one at Georgia Tech, I think, I'm not sure. But anyway, there's several of those. So certainly, and from the National Science Foundation, the research is not defense oriented, but you certainly have opportunities for getting funding from the Department of Defense, be it from the Army or the Air Force or the Navy. Yeah, they're all interested in this. Now, regarding money, again, The money has to be appropriated by Congress or it comes from companies. So
But
those
the basic research is still coming from the government, not applied research, but basic
the
research.
basic research does come from the government. Although nowadays, some of the companies are also interested in basic research, but their funding levels are much smaller for basic research. They're more than happy to give you a lot more money for consulting,
The
but
companies are
but-
glad to use the basic
Right,
research for
right.
their profit,
that's right.
as long as somebody else
Yeah,
can
yeah,
fund it.
right. But-
Privatize the
Yeah.
profits, socialize the cost.
Yes, but we do have, for example, even in our institute, we do have
Sure.
funding coming from a variety of different companies. And Cisco is making a fairly large scale investment in various researchers. Google, we have Facebook, Meta, and so on. So it's a combination.
Sure.
What's the main kind of pushback you're seeing from companies in adopting AI?
I think the two types. One is to make sure that their data doesn't go out. So for example, a lot of companies don't allow their employees to use tools like ChatGPT because they're afraid that the moment you ask ChatGPT a question, it's stored in the OpenAI servers, and so that's a problem. So that's one. The other one is that, if you have a traditional company that's doing things well, and especially if it's safety related, they're very cautious, and they should be when they want to adopt AI. So they want to make sure that, that by adopting something, things don't go badly. Please.
Okay. And we talked, and you're welcome to ask more questions as we enjoy refreshments. So let's close in prayer and then know that there are still refreshments left and enjoy them and enjoy conversation and further discussion. Okay, let us pray. Oh God, we thank you for this time, and we thank you again for Ness and for his teaching, for helping us to understand. And Lord, we pray that you would bless this process ahead, that you would help us to put the right guardrails in place and to spend money that will benefit many. We thank you for the opportunities ahead. And we pray, oh God, that you would guide and help. We thank you. Amen. Okay. Well, thanks to Dr. Shroff. Oh, thank you. And I do have, that question at the end approaching was, are you afraid of military uses?
That definitely. The ones are being released. I think that is unfortunately.
Almost like it's almost as if the US needs research to stand.
I think AI is the next one. If we need to use this to try, we will be certainly significantly. Absolutely. I mean, I don't have enough knowledge to answer that question, but I don't think so. It's not a nuclear weapon. So there are a few things. One is this information that comes from. So right now, the goal of the foreign assistance is that's essentially. And this is especially true because they certainly want to make sure that democracy is. They're not in the democratic. Yeah, so there's that. The other is, of course, things like just unmanned dangerous technology. Yeah, ships, things of that nature. And that's where the research is more. So right now, the US it's crazy how that's yeah, it is certainly a technology that's going to use to develop better and better other technologies. So that's why we want
Well, and you want to get some refreshment. Sure. But you can chat as you. Yes.
Careful of the wires. Oh, I know. Make sure. Interesting. I know it was, I was talking to his, I didn't know it was his daughter and wife. And I.
sorry.
So I think we need to ask that if we